Hi everyone, welcome back to the ML Algorithms Coding series. Today, this is the 10th session of the series. If you haven't watched the earlier sessions, please, I'll recommend you to go back and watch the earlier sessions. So in this particular session, we were already, in the last session, we were discussing about neural networks. And in this particular session, we will be discussing about the convolutional. So the convolutional is, I'll say, a building block for the CNN's convolutional neural network, which we will be seeing in the upcoming sessions or series. So convolution is something that helps us to convolute. So maybe I'll explain you with the help of a code and a diagram. So here in this particular code, we will be discussing about two things, the convolutional for 2D image and the convolutional for 3D image. So before diving into the code, I'll explain this thing with the help of a diagram. So for example, I hope you have basic understanding of what images are. For any image that we have generally, it's divided into three sets. It can be in pixels, it can be defined as a set of combination of three colors for each pixel, like red, green, and blue. In each of the red, green, and blue, it can range from either 0 to 255. And in case if it's a grayscale image in the all three dimensions, red, green, and blue, the image will have the same value of numbers. So I think like you have that understanding. For example, let's say for example, in this particular image, the pixels that we get, we are just considering only one dimension. Let's say for example, only one dimension. And for example, if this input comes out to be this particular pixel. So what we will do is we will try to apply a kernel on that to extract the features for that from that. For example, in this particular image, we might take features of the curve, straight line, edges of or where the color is changing to extract the different feature maps. From those feature maps, we might extract some more feature maps and we keep on explaining different feature maps different taking combinations of ensembles and trying out different things, not randomly, but kind of a semi-random where we have decided like these things might work, and then based on that, trying to find out those things. So and that's like you extract a lot of features and then you make an ensemble and ask the neural network or the convolutional neural network to find out what might be the pattern between these extractions samples that we have find out. And let me tell you one thing, this for the past sometime like our newer transform models have come into play, but mostly for images cnn's does the magic. All right, so particularly understanding what cnn is convolution is doing here is, let's say for example this is our input image. Here on this image we'll particularly apply this kernel filter. So kernel or filter which might be in this case trying to find out the edges. I'm saying randomly, but this a particular something that we are trying to extract from this particular image. So what we will do is we'll select the image patch of the same size as what we the kernel that we have. For example, 101.0.1.1.1.1. And in this particularly, we'll multiply 1 with 1, then 0 with 2, 1 with 3, 0 with 4, 1 with 5, 1 with 6, 1 with 7, 1 with 9, and then add everything to get the first element in the output that we have. Similarly, we'll get the second element, third element, fourth element, and similarly, we will fill the whole matrix that we have. So this is what's happening in convolutional. And sometimes what happened is earlier we had 6 by 6 matrix, but after applying this filter, we had only 4 by 4 matrix. And in case if we want a 6 by 6 matrix again, so we will just put a boundary besides this particular input, also known as padding. And in that, if you apply one boundary here, one boundary here, one boundary here, one boundary here, you will have this thing as 8 cross 8 matrix, and in that the first element that you'll have is somewhat this one, and based on that one you'll have the kernel, you'll be applying filter on each of those and you'll get an output of 6 by 6 cross matrix. So let's try to code this thing what we just understood. Here we defined a convol. It's like it takes to input the signal that we have and the kernel that we want to put, and the output that we want, we have initialized it as a null. So kernel size, we have specified the kernel size, then we have put padding across this, and then we are just doing padding. You're just adding the signals in the padding. You're just adding zero in the paddings. So for the boundaries, we are adding zero, but we are adding the dimensions there. And then finally, we are running this thing for the whole dimensions of the padding that we got, like for the whole dimensions. For that, we are seeing for the everything, for the range and kernels for each for the kernel size, we are seeing like a sum equals to kernel j into padded signal. So what we are basically doing here is for this input patch that we got, we'll multiply this thing by the kernel filter that we have and get and add up all the entries to get the first element. And similarly, we'll run the loop for each and every image patch that we have. So here we said like for each and every image patch that we had, we'll calculate, we'll apply the filter and then sum it up, and then we'll add that sum to the output, and then we'll run this thing in whole loop, and then we'll find that particular convolution of 2D. And this is, I think, very easy to understand. So similar thing is what we'll be doing in 3D. However, here we will add one dimension, and one thing that might change is we might take one more input, one more loop in the sense of one for width, one for channel, and one for the height that we had. So in case if we had this image, we applied this kernel and this kernel, so we'll get the output of this thing. So yeah, that's it for this thing, and I hope you understood the method of convolution. In case of any feedbacks or comments, please let me know in the comment section, and see you in the next session or the next series. Thank you.